Hi, everyone. Thank you for joining today's webinar. We thank you, everyone, for taking your time to join our call today. We are waiting for a couple of minutes, and then we are going to start. Let's wait for a few minutes for others to join, and then we are going to start our webinar. Thank you. Hello once again. Yeah, thank you again for joining today's webinar on EUDR, European Union Deforestation Regulation. I thank you again for taking your time to join this call, and we hope it's going to be insightful and helpful for everyone for fighting against the deforestation and also fighting against the climate change. So we are going to have a look of the power of technology and on how the power of technology, including Earth observation, can contribute to fight deforestation and global climate change. Without further ado, I will start with the introduction. This webinar is prepared by LADA 360, based in Tanzania, in collaboration with Remote Sensing Solution, RSS, from Germany. So we are preparing this webinar in collaboration of the two companies, one from Tanzania and the other one from Germany. So I will go on introducing LADA 360. LADA 360 is a space tech company that uses satellite data and AI analytics for agriculture monitoring, forest monitoring, and error warning system. So we are providing solutions for agriculture monitoring, including digital platform that is used by farmers to monitor their crops from planting to harvesting, having the access of the crop health, soil data, yield prediction, soil classification, crop classification. So our company has developed a platform called LADASpace that is using satellite data and AI analytics for monitoring of crops from planting to harvesting and having access of crop data yield prediction, soil classification, crop classification, crop health, and different kind of data, including the weather data. But also we are providing solution for forest monitoring, including agroforestry projects and tracking deforestation. We are also providing solution on early warning system, including the analysis for climate hazards, including flooding, drought, land degradation, and wildfire. All of these we are using satellite data and AI analytics for providing this kind of analysis. So we are based in Dar es Salaam, Tanzania, and we are serving the industry of agriculture, forestry, and early warning system. So that is a brief introduction of Ladder 360. I will take this chance to welcome Dr. Max from LSS Germany to give us the introduction of RSS and their operations. Welcome, Max.
Hello, thank you, Musa. Welcome from our side here from Germany. Just a few words to myself. My name is Maximilian Schwarz, or just Max shortly. I'm with RSS for nearly 8 years now and mainly responsible for projects in Africa, ranging from different topics from climate smart agriculture to drought assessments, but also to forestry, afforestation, deforestation, but also carbon projects. And I'm here today with my colleague Anna.
Hi. Yeah, thank you, Maxi. I'm also part of RSS, working at a remote sensing and AI specialist for 2 years now. And yeah, I have been mainly contributing to the deforestation model development, also closely collaborating with our software development team, working on our EUDR compliance check platform and also reporting tool. And generally, I'm in all the projects where we apply deep learning models for environmental monitoring.
Okay, I just quickly share my screen so I can give a quick introduction about RSS, and then Anna will continue to give a quick introduction about EUDR in general before we start the, let's say, more technical content of the webinar. Quickly to RSS. We are an SME based in Germany. And we work in several sectors and also have several customers and partners, from public institutions to private companies, different sectors ranging from forestry to natural hazards. So not only deforestation or carbon projects, or in this case, EUDR, but also different nature-based solutions or monitoring systems in other sectors as well. RSS is existing now for nearly 25 years, and we're one of the leading value-adding companies in Germany in the Earth observation sector. And what also is maybe important in this regard, we also work together with different organizations to set standards for methodologies, for example, in the carbon sector, for example, for verified carbon standards, where we worked, for example, together with Vera, which is probably the most known institution in the carbon sector. Yeah, that was quickly about RSS. And now Anna will give a quick introduction about EUDR.
Yeah, so as probably most of you have already heard from the EUDR, we'll keep it short for now, but yeah, it's basically a new EU law which requires market participants who import or export certain commodities from the EU to ensure that those commodities are sourced from deforestation-free production sites, since the cutoff date, which is the 30th or 31st December 2020. And the relevant commodities are coffee, cocoa, palm oil, rubber, wood, and cattle. And on the next slide, we can see the different components of the EUDR regulation exactly. So first component would be to have all the geolocation data from your production site. So there Musa will also give you more details on, so I will not go too deep here, but for all the production sites, you do your due diligence statements, you would need the coordinates of the boundaries. Then a legality assessment is needed, which includes information on or proof that the commodities are produced in accordance to the legislation of the country of production. So, for example, no child labor is involved or anything like that. Then the core, which is also the main part of the service we offer, is the deforestation check. So you would need to prove that the production sites are deforestation free since the cutoff date. And with that comes also a risk assessment. So additional information is required on the deforestation risk of the jurisdiction of the production site, meaning the forest extent, deforestation extent, or for example, presence of indigenous areas, etc. And then in the end, there comes the reporting. So together with the due diligence statement, additional information is required, like the proof that you did a deforestation assessment, and that can be delivered via a report or API. Yeah, and with that, I would hand over to Musa to give you more details on the proof of origin.
Thank you, Anna, for the highlight of the EUDR requirement for different crops, including cocoa, coffee, palm oil, soybeans, and rubber, even wood. So that's some of the products that need this compliance, though it may expand to other commodities later. So I would like to take this chance to welcome our CTO, Maria Goret Abel, who is from RADA, who will give us a brief introduction of geolocation collection. So Maria will take us through the geolocation collection in proving traceability. How do you collect the data point and then the geolocation that is ready for EUDR analysis and reporting. So Maria, can you share your screen?
Can you see my screen?
Yes.
Can you see my screen?
Yes, yes.
Okay. My name is Maria Goret Abel. I'm the CTO of RADA 360, and also I'm the GIS and remote sensing specialist. I lead our geospatial and remote sensing work, integrating satellite data and the geospatial technology in solving real-world problems in agriculture, forest monitoring, early warning, and sustainability. Here, the QR code you can scan, and it will dive you direct to the website where you can be able to explore different services that we are providing. So today I will take you through geolocation, mapping the farm boundary that is required for EUDR compliance. When it comes to mapping farm boundaries for the EUDR, the approach depends on the size of the farm and the field condition. For the smallholder farms, mobile GPS tools like Map.gis, ODK Collector, and QFeed can be used to collect the coordinate point. And these tools is directly available in the App Store or Play Store. You can easily download them and use it in your mobile phone. And they work well in offline in areas with low connectivity, which is common across in rural Africa. And for the large farms, you can digitize direct using the Google Earth Pro, where you can be able to draw each boundary, each point as seen in the Google Earth Pro. For example, this farm, it's a palm oil. You can be able to digitize using the Google Earth Pro, and you can be able to store your farm boundary. And also you can use the coordinate point like this one. Can be able to store latitude and longitude and the attribute table. And so, and for those who have their existing digital data, like they have already GIS boundary, like in form of shapefile, KML, and SSB are highly supported. So the key requirement for EUDR is that all boundary must be captured in WGS84, that is latitude and longitude, because it's a global data, and it avoids coordinate to shift during processing. Because using other coordinate reference system like Universal Transfer Mercator, which is known as UTM, can misplace the farm boundary. So it's good to use the WGS84 as a global data, because it can prevent a high risk classification. If a farm may be shifted to 50 up to 100 meter because of long coordinate reference system, it may fall inside a deforested zone or outside the real farm. So this can wrong mark a compliant farm as non-compliant. An accurate geolocation is not option for the EUDR, so it's the core requirement, because if the boundary is long and even a small shift, it can incorrectly classify a deforestation-free farm as a high risk. So it's strongly emphasized on accurate GPS capture and the proper digitization and the use of standard GIS format. For the required file format that is acceptable for EUDR compliance is that all GIS compatible formats are accepted, and most are like GeoJSON, shapefile, KML, CSV, or in form of well-known text which represent a polygon in text format. So all boundary that are in GIS format is accepted, and with additional information in the attribute table like farm ID, the crop type, if it's coffee, cocoa, or any export commodity. So this format can ensure the interoperability with GIS system, so as it can allow the processing in an accurate way. So using the correct file format and the proper geolocation, ensure the boundary can be processed accurate. So if the boundary is digitized in a long coordinate system, for example, UTM zone or ARC 1960, its position can shift on the map and may fall into the long risk zone. So both format and the accurate direct affect the compliant outcome. There are common mistakes in the boundary mapping and how you can fix them. So these are the common frequent issues that we observe during the correction, like incomplete boundary, missing corners, that if you are mapping the farm boundary, you need to map each corner without missing them. So incomplete boundary can be a big mistake and can result into wrong geolocation. And also GPS drift, like mapping using the GPS maybe under large building or under the canopy, it can collect wrong coordinate. Also using the wrong coordinate system like UTM zone, and also using an outdated imager for digitization. Also missing metadata such as the crop type, because it can be harder for the one who is processing to know which type of the crop is available in that field. So the solution are straightforward. Use the offline capable tools like the Map.gis, which you can be able to use even in low connectivity. Also, let the GPS to stabilize before mapping, and digitize your field using the recent satellite imager and exporting required coordinate reference system, that is WJ84, and also avoid and enforce the consistent naming to avoid duplicate. And also, so this small practice can dramatically improve the quality for your EUDR submission. Thank you for your attention. If you need support with boundary data correction, data validation, our team is here to assist. Thank you.
Yeah, thank you, Maria Goretti, for the presentation on geolocation data collection. So Maria Goretti is working at Ladder 360. We are based in Dar es Salaam. So we are ready to assist in case of you need any clarification on data collection. You can just reach out to Ladder 360 and we can assist. Before we continue to the next step, I would like to ask for anyone who has question. You can start dropping your question on the chat box. But after the presentation, we're going to have a Q&A session. It's going to be for like 30 minutes, so we are going to have enough time for questions. So you can keep your questions or start dropping them on the chat box. So after the last presentation, we are going to respond to all questions. Yeah, Maria, can you stop presenting? Yeah, so we are going to the next part of the webinar. Anna will take us through the analysis part. It's more of what is happening in the behind to provide the report after data correction. So we are going to see what is being analyzed. If you have heard, we are using satellite data and AI analytics for analysis for tracking deforestation. So Anna is going to take us through what is happening behind. What is the technology behind? What kind of data is used, and what kind of analysis is being done to prove risk to deforestation and provide the accurate data. So Anna, you are welcome for technical part of what is happening behind. You're welcome.
Yeah, thanks a lot, Musa, for the introduction. So first, why do we even use satellite data to check for deforestation? And the main reason is that we really need an efficient monitoring and verification system to check production sites globally, continuously. And therefore, satellite imagery is perfect because it allows us to have that large scale view and also go back in time. And in combination with an AI algorithm that can detect deforestation, we can then automatically and efficiently check a large number of production sites at once. And moreover, since that information is data-driven, it's really objective and also transparent because we really have the imagery behind our detections. And the most straightforward approach, which is actually often used for deforestation checks in context of EUDR, would be to just check if the production site has been covered by forest at the cutoff date, because then you could assume that it has to be deforested afterwards to serve as production site for example, soybeans. And for that, generally global forest cover products are used, but that can quickly lead to incorrect assumptions of non-compliance for several reasons. So on that slide, you see 3 different global forest cover products on the left side. Those are also publicly available. And on the right, you see a locally calibrated forest mask by RSS. And yeah, as you can already see on first sight, the forest extent differs quite a lot, which is because the global products are often very inaccurate on a local level, mainly because they fail to distinguish between plantation forests and natural forests, which is a really huge problem, especially in context of EUDR, since most of the relevant commodities, like for example, palm oil, cocoa, coffee, rubber, they grow within plantations or even as forests, like in type of agroforestry systems, for example. So just saying a forest at the cutoff date implies deforestation afterwards would lead to a lot of false positives. And last but not least, global data sets are often at best made available once a year, but they don't show any real-time land cover of the production site, which is also very important for EUDR. So what we did
Anna,
is, yeah.
just quickly, can you change the view of the PowerPoint?
Do you see
the presenters mode? Yes.
You see the presenters mode. Okay. Thank you.
Yes.
Better now. Thank you. So yeah, how did we approach that? We trained a model to scan the whole satellite time series available. So we use Sentinel-2 data, which is available approximately every 6 days, and check for deforestation. And we used a UNet architecture, which is a very well-established segmentation classification model, which classifies each pixel of an image. And initially, the model is trained for monotemporal classification, but we adapted it to be bitemporal, which means that it only detects new occurring deforestation or forest degradation. So we train it on a pre-deforestation scene and a post-deforestation scene, stacking that together. And then, the model would learn how it looks like when there was a forest in the pre-image and deforestation in the post-image, and only that would be the pattern we are interested in. And in the end, we had a deforestation and a degradation class, and we also trained the model on different forest ecosystems, like, for example, tropical forests, deciduous forests, or coniferous forests. And most of the effort actually went into a well-curating training database. So we manually labeled almost 2,500 deforestation examples and 1,500 degradation examples. And then, which was the main effort, was that we started letting the model run on test sites, and then saw that, for example, it's still misclassified plantation clear cuts, so deforestation on plantation forests. So we took those examples, labeled them as background, and then fed it back into the model. So step by step, the model would learn to not misclassify or confuse any plantation clear cuts with the deforestation under EUDR definition. And same, for example, for phenological changes or cloud cover. So any patterns which could easily be misclassified with the deforestation or degradation we were really interested in, we gave a lot of examples as a background class to minimize any false positives. Here just a quick example on how the training and test scene distribution looked like in Indonesia in that example. So we, of course, took training and testing data of different countries worldwide. And we tried to make sure to have a lot of different landscape patterns present in the training and testing data, and also that the testing data is spatially and temporally independent from our training data, so we could ensure a representative, quantitative, and qualitative accuracy assessment in the end. Then after fine-tuning the model, we applied it in the cloud to the whole satellite time series, so all available satellite scenes. And we didn't apply it on the whole scene, but using a tile-based approach, so going like on smaller tiles one by one. And we first look for the first cloud-free tile closest to the EUDR cutoff date, and then would this scene or tile would serve as the first pre-scene in the algorithm. And then we would compare it to all following up tiles, even though they had extensive cloud cover on them. And that way we also made use of even like very small cloud gaps, because clouds were also a major problem, especially in the tropics. And by also working with cloudy scenes, we made sure to not miss any deforestation event, even though, yeah, we might have quite a lot of cloud cover. And then the next completely cloud-free tile would serve as the next pre-tile, and again be compared to all following up available scenes. And yeah, I brought a small example on how the predictions looked like in the end. So here you can first see the underlying satellite image, and then on top the predictions by the model. And the darker the color of the prediction, the more recent the deforestation event has been. This is a subset from a region in Brazil. I also brought an example on degradation. So here we are in Indonesia, and the blue segments show selective logging, and the yellow ones show deforestation again. Yeah, so with that, I already come to the summary of the key features of the algorithm. So basically, we scan all available satellite scenes from the EUDR cutoff date to the latest available scene to really have a near real-time deforestation and degradation monitoring, and only flag a production site as deforested in case we really see the deforestation happening. And we can also provide the underlying satellite imagery, which makes the approach very reliable and transparent. Moreover, we trained on different ecosystems, so the model works in agricultural areas, and also on different forest types, as for example, tropical forests or deciduous and coniferous forests, as we have them in Central Europe, for example. And then we apply the model completely automatically in the cloud, and we also specifically apply it on the production side. We don't need to compute a whole satellite scene, but the model works on production sites, which makes it a lot more computationally efficient. And then in the end, all the outputs and results, together with the corresponding satellite scenes and also additional information layers, are pictured in a digital monitoring, reporting, and verification platform. And yeah, I'm going to give you a demo on that now, so I don't need to go too much into detail, but yeah, I would continue with the demo now. And if you have any questions on the model so far, please also place your questions in the chat. And now I just need to make sure that I show you the right screen.
Yeah, I think there was one question already, if we can share the training data sets, but that's unfortunately not possible. So you can always come to us if you have any, let's say, test sites or any questions regarding the algorithm, but we cannot share the curated training data sets that we use for the algorithm, just basically because that's our business model. So we cannot share the training data set, but there are different, let's say, freely available data sets available on the internet for AI models, not only in deforestation, but also on other stuff. So if you want to build your own model, you can either, of course, create your own training data set or look in the internet. And the same, I just saw the question, we cannot share the final model code. We can share results if companies are working with us, of course, because that's the aim of it, but we cannot share the model or the training data directly.
Yeah, thanks, Maxi. So are there any other questions, or should I continue with the demo of the platform?
So far, no further questions in the chat, so you can continue.
Can you see the screen with the platform? Okay, perfect. So entering the platform, there are different, it's a digital monitoring, reporting, and verification platform, and we have a special module called supply chain for EUDR checks. And being a customer, you would have your own login and then have an overview of all the onboarded production sites. So we would need the geolocation data for each production site and then onboard it on the platform. And then you would have an overview of all the sites on the left and the map, also with the symbology and distribution of the production sites. We now onboarded different test sites, in different countries, as you can see. And I'd start by showing you one test site located in southern Germany. So here the commodity is wood. You also see an overview of, okay, why doesn't it show all the information layers? Let me check. Now there we have it. So on the dashboard below, you can see all the site data. So with the statistics like size, commodity code, and also commodity. So in this case, it would be wood. Zooming further in, we can see in high resolution satellite imagery of the production site. In this case, we only got a point coordinate. So we made a buffer around it and checked for deforestation within that buffer. Picturing the deforestation, we already see that there are 3 different disturbance areas. And then we have the deforestation satellite imagery with the corresponding scenes where the model detected the deforestation. So here we can see that, for example, in this spot, we already see the clear cut. And then we can go back and see, okay, here in beginning of 2024, in this case, the deforestation hasn't happened yet. So that makes it very transparent, as we can really see the deforestation in the image. Additionally, we can picture other information layers as, for example, active fires. I assume that there aren't any active fires in Germany right now because it's really cold and rainy here. But maybe in other countries we would see some fires now. Then we have a global forest cover map onboarded with a certain buffer around the production site, as well as forest height, for example, and a land cover data set. And additionally, we can picture a trend analysis which shows the NDVI trend, which is an index representing vegetation health. And as we can see here, we see the phenological changes. So the vegetation health goes down in the winter because the forests, lose their leaves. And if we would see a real cut with a longer time frame of very low values, that would also indicate, for example, deforestation. Then we could maybe jump to another site in Brazil. So showing the deforestation predictions, we see that there happened quite a lot. So again, watching the underlying satellite imagery, we could maybe see when the deforestation occurred. So here we can already see, okay, it developed over time. In 2023, the deforestation wasn't that developed yet. And in 2021, here it's a little more cloudy than in Germany. But we see that 2021, most of the forest was still intact. And again, we have the additional information layers as forest height. And of course, we have the site data again. And we also have the possibility to export all that information either as PDF report or CSV. So I will also show you an example of a PDF report in a minute. Before, I would maybe jump to a site in Tanzania first. So here we have an example of a coffee plantation, and we see that there aren't any deforestation alerts on the site. So we also don't have the underlying satellite data since, there hasn't been anything detected, but we can still still overlay, for example, the global forest cover and also watch the vegetation trend. So here again, we have the phenological changes, but everything looks normal, I'd say. And with that, I would now jump to showing you the report. Again, if you have any questions concerning the platform, feel free to post them in the chat. Also, did I miss any new questions or can I continue?
You can continue, Anna. There were no further questions for now in the chat.
Perfect. So as I said, all the information we can derive in the platform, we can also export as a PDF report, which is then really helpful to integrate in the due diligence statement market participants would need to submit for the checking authority. And we made a little demo report showing interesting test production sites, which is composed of a cover page, table of contents. Here we already have the link to the production site assessments. But starting off, we have a small overview with statistics on the different countries. So we have the total area of all production sites and also number of plots. In this case, it's quite small, so it's only 9 plots within the report from 4 different suppliers and 4 different countries. And as we can see on first sight, all the production sites coming from Brazil and Indonesia are having deforestation alerts. For Germany, 2 of them. So we had 4 test sites in Germany. 2 of them as well have deforestation alerts. And the 2 test sites from Tanzania are deforestation free. Then we also have a supplier specific statistic, so showing how many of the suppliers within the report have disturbance alerts, as well as the share of deforestation free suppliers. Then continuing, we see a table summarizing all site statistics, basically. So again, having the commodity codes, area, compliance status, location, and links to then a more detailed production site assessment. And for each production site, we provide a very high resolution Google satellite imagery and the corresponding JRC forest cover data set. So that's a global forest cover data set. We compared quite a lot of different global forest products, and this one is the most accurate. It still can have some misclassifications, which is why we then additionally need the deforestation check. But it's still interesting to see the forest share on the production side. And then here you can see an underlying satellite imagery closest to the EUDR cutoff date. So for Germany, we have a snowy image because it's in winter, and then a latest satellite imagery. And I don't know if you can see it now, but there we also already have quite small all the model detections on top, together with a pie chart showing the area share of forest disturbance. So in this case, it's quite small, which is why we then additionally have a more zoomed in view, showing the model detection together with the satellite imagery, the model used to detect the deforestation or degradation event. And on top, we have the areas. So in this case, we only have deforestation, which is also quite small. And moreover, we provide a buffer zone analysis, which is also relevant for the risk assessment. So we show the forest share within a 20-kilometer buffer zone around the production site, as well as clear-cut or selective logging alerts, and any additional information layers which could be different depending on the region. So for Germany, we have a layer showing nature reserves. For other countries, we have other additional layers. So this is quite dynamic. Also, if a customer has its own additional information layers, which could be interesting, those could also be onboarded here, as well as, of course, on the platform. So I would go a little faster here. So again, a German test site with different deforestation detections. We also already saw that on the platform. And 2 other test sites showing no disturbance events. So here we have a low risk for deforestation. And then this parcel is in Brazil, and as we can see already in the satellite image closest to EUDR cutoff date and the latest satellite image, there has happened quite a lot. So picturing that on a larger zoom scale, we see that here quite a big part of the forest has been deforested, and then also continuing with smaller parts. So the clear-cut region grew over time. And we also always provide the specific dates. So you could also check when the deforestation event happened. And again, we have a buffer zone analysis this time, including an indigenous lands layer. Yes, then maybe I will also go a little faster here. This one is another example from Indonesia. And here we have selective logging detected. So this is shown in this orange color. And as you can see on the zoomed in view, we have the deforestation part on the left, and then just some degradation, selective logging happening. So we also detect that, even though it's not deforestation under EUDR, but it's also relevant for the deforestation risk, as selective logging often occurs in advance of a deforestation event. And in this case, we have onboarded a palm oil layer in addition to the JRC forest mask and our model predictions. Then we also onboarded 2 other test sites Musa gave us from Tanzania. So here we have coffee plantations again, but no deforestation or degradation event happening. So we again have a low risk for non-compliance. And with that, I'm already at the end. I'm happy to get your questions and feedback.
Yeah, thank you, Anna, for a great presentation. Thank you for a nice presentation, Anna. So I would like to now invite the audience. I think we still have enough time for Q&A. I invite the audience. If you have questions, you want more clarification, or you want to ask something related to your scenario or related to your crop, if it's cocoa, coffee, palm oil, soybeans. So the floor is yours now. You are welcome to ask any question related to your live environment, because we know this is the new regulation taking place. So you might have a lot of questions that need clarification. So the team is here to give you more elaboration regarding to how EUDR is applied. So you're welcome. Maybe you can raise up hands on the chat. I can, if you have questions, you can raise up hands. So invite questions, ideas, or any contribution, any feedback related to EUDR from your end. Yes, Josephine, you can unmute and ask your question.
Hello, everyone.
Hello.
Yes. Lego Josephine from Cameroon. I want to appreciate the work that you have been doing, and it's very interesting. I had 2 questions. I asked in the chat, but okay, I will look for other way to get more accuracy when trying to delimitate the boundary of a farm based on satellite technologies. Now, my question is about the forest monitoring. Have you integrated the estimation of carbon sequestration in your solution? That's the first question. And the second question, how have you done in order to evaluate the forest height? What kind of data have you used for that? Thank you.
Yeah, thank you for the questions. First, the model really only detects deforestation, so we don't calculate any carbon metrics. And the forest height layer, you're probably referring to the one in the platform, I guess. This one is a global product. It's based on JEDI data, so on LiDAR data acquired satellite-based. So this is also not a product we created, but it's a openly, publicly available data set.
Okay, thank you. So your solution doesn't integrate the carbon sequestration.
No, since it's not relevant for EUDR compliance, we really focused on reliably detecting deforestation.
Okay, thank you.
I can see another question on the chat from Rogers. What's considered as a forestry in this new regulation? What is it considered as a forest in this new regulation?
So the forest definition follows the definition of the FAO. And it's I can also post the link in the chat. But everything larger than 0.5 hectares and more than 10% of canopy coverage. And then there's also a forest height, which is relevant to the definition. I'll look it up in a minute, but I can also post the definition in the chat.
Yeah, I think it's higher than 5 meters and more than 10% canopy cover. I can quickly post it as a comment, the link to a PDF with all the definitions from the FAO.
Yeah, there is another question from Muhammad. Muhammad is asking, for the platform, could we get more information for replanting forest beside the deforestation?
So since the platform also has other modules, like for example, the module called Verified Transparency, there we also monitor afforestation projects, so we can definitely also monitor replanting of forests and other environmental monitoring tasks. Maybe Maxi can tell you a little bit more about it because I'm not involved in the verified transparency section. But yeah, we can also monitor that.
Yes, so I just checked, I just sent the link again to the platform, and the basic homepage that you can also find on our website is for the Verified Transparency platform, where you can find some basically test sites, as we showed here for verified supply chain, which is for EUDR. We have verified transparency for afforestation and forest regrowth, and you can find some test sites. And we also have some different information layers there, so you can follow your projects. Basically, something similar just for another course. And the platform, I mean, itself, we have some free to use, let's say, test examples, but in general, the platform is not free to use. So if you want to have a project onboarded, when it comes to EUDR now, we work in a cooperation with Radar 360. So this is a joint effort together. So you can either contact Radar or us, RSS, and then we're happy to talk about individual solutions for different farms, different farm sizes. In general, what we can say is that the price per hectare, as it is in rental apartments, for example, is lower the more area you have or the more test sites you have.
So regarding the other question posed by Robert, so in case it's really just bush clearance and not deforestation under EU regulation, we trained the model on distinguishing natural forests and, for example, bush regions. So it shouldn't be flagged as deforestation in that case.
Yes, and then also comes into the forest definition. So if the bushland is not considered a forest, then of course it's not part of EUDR. So you're not going to be a victim of this regulation in that case. But if it's, how you call it, a virgin land of forest, under the definition of forest, then of course it falls under the deforestation regulation, and this land would be non-compliant to the EUDR.
There is another question. Is the platform only for farmers or even exporters can find it useful?
So it's basically useful for all market participants, since everyone needs to do the due diligence statement, and having the platform and also the report, gives you a reliable information on if your production sites or the production sites you source from or export from, so within your supply chain in any way, is compliant or non-compliant.
Yeah, exactly. Maybe just one more comment regarding that. I mean, mainly, let's say, if you are a farmer not exporting directly, the EUDR due diligence is not necessary for you. So basically, the organizations that are exporting to the EU or importing into the EU, they have to hand in the due diligence statement. So they would need to use, for example, the platform or hand in the reports and the due diligence statement. And then if they come and ask for, I don't know, for example, for your boundaries of the farm, then that's what you would provide them. And they would basically do the EUDR due diligence statement together with the deforestation, for example, with our platform. If you are a farmer that directly exports to the EU, then this would be also something you would need to do.
So we invite other questions from the audience. If you have any question or comment.
Yeah, we're also happy to get any feedback, for example, on the platform or the report, since everything is still under development.
Yeah, so while we are waiting for additional questions, maybe to add on what Max said, we are currently inviting all stakeholders in coffee, cocoa, palm oil, soybeans industry. So if you have your project or any farm, or you are planning to export in the EU market, we are looking to assist you in your project. You can just reach out to us, and we can plan for an analysis, reporting, and all kind of relevant data that required for EUDR compliant. So you can just reach out to Radar 360 or RSS, and we can help you regarding EUDR related issues. Any other question from the audience?
If you have questions later on, you can, of course, reach out to us also after the webinar.
Yeah, there is a question on the chat. The support is free or paid? Yeah, so this service is a paid service. Is a paid service. So if you have a farm, let's say a coffee farm, cocoa farm, we will assess the size of the area. What is the size of your project? And then we can provide a pricing based on your site, area size. Yeah, so simply it's a paid service and it's related to the size of your farm as well. Yeah, so reach out to us. We are open for discussion. So we can help you in data collection, analysis to the report, and we can give you the affordable pricing package for your farm size. While we are waiting for other additional questions, maybe Max, you can again take us through what's the services of RSS and also the services of RADA, maybe for addition as a reminder for the audience while we are waiting for other questions.
Yeah, so basically, what we provide from RSS is just one part of what's needed for the EUDR due diligence statement, which is mainly the deforestation check with the AI model that we developed in-house that Anna presented. That generates basically a report, which is one part of the due diligence statement that needs to be submitted. Then there are, of course, additional legal requirements where we in Germany, of course, are not the experts in local legal matters in each country. But especially in East Africa, that's, for example, something where RADA could help you. And also, when it comes to geodata collection, RADA would be the contact here. And so we work together in that basically EUDR field, both companies, so we can assist you with as much as possible what you need for the EUDR compliance. And then I think so there was a question for you rather.
Yeah, so can you give us access for ED prediction analysis support? Yeah, so Gadisa for ED prediction, you can we can get in touch. We have a service for ED prediction through our other platform called Ladder Space. I put again my contact email. We can get in touch after this webinar and see what kind of yield prediction you need for which kind of crop, and we can see how we can assist on that. We have the models for yield prediction. Any other question, comment, suggestion from the audience? You can just unmute your mic and speak. So if there is no further questions, yeah, Gadisa, yeah, no problem. Please, you can give us your data on the crop yield prediction, including which kind of crop you are working on, and we can see how we can work together on that. Yeah, so I will write to you guys the follow-up email in case if you have a project of these EUDR related crops. We would like to work together in assisting you and supporting you to comply with EUDR. So I will write you an email and we can plan for support and collaboration from data collection up to reporting. Max, do you have any other additional comments?
No, if you have any questions, just reach out to any one of us, either RSS or Radar 360. And we're happy to answer any questions that you have. And also, of course, would be happy to work with any of you in the future.
Yeah, thank you, Max. Anna, any comment?
No, same what Maxi said. And yeah, thanks for listening and thank you for your interest.
Yeah. And also, thank you, Max. Thank you, Anna, for a nice presentation. Thank you, Maria, and thank you, everyone, for taking your time joining this webinar. This is just the start. We are looking forward to work with you, everyone. I will write you a follow-up email, so please don't hesitate to reach out to Ladder 360 or RSS, and we are looking forward to work with you on your project related to EUDR. Thank you so much. Have a great weekend.
Thank you. Have a nice weekend.
Thank
Bye.
you.
Okay,
Bye.
bye-bye. Bye-bye.
Thank you.
Thank you.
Thank you.
Thank you. Bye-bye.